Going back to test the areas, um, weight of the object and the thrust rate against the weight and the weight of fraction, the fraction of the area. So that area is determined by this metric range as of the torque of this rotary, the size of the propeller, and the torque, force, energy, speed, and velocity of the emission. So that if this takes 10% of the mass or the entirety of one propeller against the mass, which I very would think that this would only take up a proportion of this area or fraction of weight. It could probably take 50% of the size of the mass, just this propeller thrust alone. Now, this propeller is of the frontal. I try to use one that will probably cover a minimum. I think it's too long. I can shorten it. But I needed to take up this mass right here. So say this was divided by proportion to be able to take this mass to lift this mass into the air. Now, this proportion, say if this was cut around here of this mass, and that the rotation, torque, energy, velocity against the inertial weight should be able to lift this in the air. Of this mass. So this mass is weight on the scale. This is aluminum. So this mass was weight on the scale. Just cut that part. And the weight on the scale for the torque, energy, velocity is lifted into the air. So this, in addition to this mass, in addition to this mass, fraction, area fraction. The area and of the fraction. This is the area, and this is the fraction of the area. So this fraction of the area, if it's able to move this fraction of the area, then I would need more thrust to move this fraction of the area, which is this for. This is the reason this for. And more thrust to move this area fraction of the area if this was divided. So this is the fraction, this is the area, and this is the fraction of this area. Now, here for the rotary, for motion to escape, also for balancing. Now I have it fixed in an L shape. Placed it in L shape so that it would have a gyroscopic force. I also applied legs to it, glued legs on it so it allowed it to stand. So therefore, using battery is not charged, and this is speed. That's not more speed. I'm using all to that one battery, so it is individual torque, force, and energy. So that's one part of the faceplate. Now I will reduce the size of the propellers only determined by the RPMs above at least 30,000 or 40,000 RPMs to 60,000 RPMs. I will reduce the size of the blade. And that is of the width of the blade. It's also depending on the pitch and the width pitch of the blade and how much air pressure molecules is going to be pushed per square inch. Now, as of this that I did not try to apply into any wiring as of yet. I have a propeller that goes around the back and a propeller for the front though. And this should, my hope is that it levitates upwardly in a vertical position. I have these open clearances, rectangle open clearances for a guide. So this is like similar to the chest plate, to where for the cosplay for the guide of the abdominals, the guide down these rails of the chest. Being a vacuum to where it goes towards his chest and lands on his chest, could have to have a propellant or a vacuum to propel into the air, which will probably be a copter blade and not these kind of blades. Now, the top, I have one for the top, which does not collide with the other one while it's rotating. Then I would apply another one to the bottom, which will rotate to the bottom to have on the top all the frontal. It can move forward, and it can also levitate up and down, up and down, up and down. So that's next. Checking on the air fraction, cutting pieces of the same gluage to see how much the propeller is able to lift in that radius. And then how much torque as of the motor, as of how much grams or kilograms thrust. So my hope is to use a 10 kilogram thrust, and that will give me 10 pounds. A 10 pound thrust, which is, I believe that's a 70, I think that's a 1050 drone architectural drone motor. It's very small, it's light, it's a rotary, it's a 1050, I forgot what it's by, but I'll show you that later on in the video, later on in the videos. And my name is Wayne Morton, and have a nice day. Just to test this out.
closer. So imagine a face mask coming and landing on the face like a drone. Somewhere I gotta hide these segments so they're not visible. Or either they pop out and make a pop-out actuator blades. And I think that will be sufficient. My name is Ray Morton. Goodbye.